possible. Yeah.
All right, so let's look through 2.5, number 19, which we're basically just having trouble like algebraically matching. So first, this thing just says solve. So seeing this form, what do you think?
It's going to be an exact equation, so you can just use the standard solution for exact equations.
Okay, so the first thing I'm going to do is I'm going to think about this crap as m. I'm going to think about this crap as n. I should check to see that it's exact, so I'm going to need to calculate my and nx. So my is, let's see, minus 4 cosine x. That part's all 0, that part's all 0. Over here, I need nx. That's going to be minus 4 cosine x. Okay. Those are the same. That means this is exact, which means what?
That you can just go ahead and integrate the factors without any additional coefficient.
Okay, so that means that my solution is going to look like f of x and y equals some number, and f is going to be either the integral of m dx or also the, I guess I'd say either. It's really both the integral of m dx and n dy, assuming suitable mix and matching, right? So, um, first, looking at m and n, which of these would you like to integrate?
I'm a sucker for pain, and I always integrate the left factor first, but you can do it the other way around if you like.
Gross.
Ethan, I might come find where you live.
I think you already know. Actually, you don't know where I live. Never mind.
To be fair, the only part in there that would be particularly hard would be the secant squared.
That's just tangent, isn't it?
Oh, wait, no, you're taking the integral, right?
Yeah.
Yeah, so that would just be tangent. Never mind.
Yeah,
It's
none of
actually a
this.
pretty simple integration.
Yeah, either way, it's okay. And Jordan, I'm going to assume that when you say you're going to find out where Ethan lives, it's to go give him a hug because he's sad from having done all these horrible integrals.
Yeah, exactly. I forgot that we're recording. I really wanted to see him for Valentine's Day.
Ah, yes. You have to talk to my other half about that.
It's about emotional support. It's not a threat. It's a threat of emotional support. All right, so yeah, pick one. Sure. What the hell? Let's integrate m. So we're going to say that, all right, so f of x and y should be the antiderivative of m dx. So let's see. That's going to be the integral of minus 4y cosine x dx plus 4 times the integral of sine x cosine x dx plus the integral of secant squared, of x dx. And I guess I should pull this minus 4y out front. So yeah, like Easton says, this actually isn't so bad. It's still worse than the right one, but it's not so bad. So I'm going to get a minus 4y. Let's see, antiderivative of cosine is sine. Then I'm going to get this guy. What does that guy fall to?
It's sine squared, I think.
Yeah, that's like let u be sine x dx, and then du is cosine x. Oops. Put the dx down there. Okay, so I got my cosine, I got my dx. So that is indeed going to be 4 times sine squared of x
Over 2.
over 2. And then the antiderivative of secant squared is tangent. Pretty sure. And what else?
Constant.
And what about my constant here?
Could be a function of x.
Could
Y.
Oh, sorry, y.
Function of y.
Yeah,
Because it
could
could
be
be
a
constant,
straight
yeah.
function of y. Okay, so yeah, so now I'm pretty confident that that's f of x and y is all this stuff, right?
Great. Differentiate it with respect to y.
Ew. Okay. The good news is that this and this cancel, right?
Oh yeah,
Okay.
they just vanish.
So fy then is going to be a minus 4 sine x plus k prime of y. And I'm looking to match that against my n. So this piece matches this piece. And so 4y must be k prime of y. Okay, what does that tell me that k is?
2y squared
Okay,
plus an actual constant.
perfect. Yeah, and on these you can forget the constant because you're going to set it equal to a constant anyways.
Yeah. And in fact, actually, I think it says in the book specifically set the constant of integration to 0 on the second integration.
Yep, as it should. So all told here, I'm getting my function is minus 4y sine x plus 2 sine squared x plus tangent x plus 2y squared. Grab them on space here. Equals some constant c. Good with that?
Yep.
Okay, now what?
So that's what I got
Okay.
as my solution. Actually, I got 4 sine squared x, but that's because I forgot to divide by 2 during the integration. The answer in the book is y equals sine x minus the square root of 1 minus tangent x over 2.
Um. Okay. I'm a little bit disinclined to do the following, but it is
I
available.
just was curious to see if you did it, if you got the same thing, and you did, minus a 2. So I'm
So
gonna guess it's the same thing, but I am honestly have no idea how to convert this to an explicit solution. Like I said, I see a y squared, and a term with no y in it at all. So I'm thinking maybe this is a square factor of
I
some sort.
I'm seeing maybe we could change tangent into cosine over or sine over cosine and maybe do some factoring, but
I tried that, but you can't factor sine out entirely. You can just factor one out, and you're left with another one.
you guys see what I'm doing?
Yep, you're basically factoring it.
Well, I'm doing something even dumber. Uh, you can plug this into the quadratic formula.
Oh, no, yeah, you're actually right. You can.
I would not recommend this. I would recommend that you just leave this right here. But if for some reason you absolutely must have an explicit solution, plug all this crap into the quadratic formula. That will work. Again, I would not recommend that you go spend your life doing this, but it is a convenient trick sometimes to know that you can use the quadratic formula even if the coefficients are functions. It still works. It's real weird. Um, the one thing I haven't done here is I didn't actually solve the initial value problem. You guys see that?
Yeah, that's true.
So it is possible that things are going to get a little easier once I get that k out of there.
I think I got c equals 3, but I
Yeah.
think it's
So
c equals 2 because I actually had a wrong coefficient.
okay. So let me let me maybe just, oops, that's not what I wanted. Let me just scoot this stuff down a little bit. And let's plug in our x and y's here. So I'm supposed to get y of pi over 4 is 0. Okay, so when x is pi over 4, y is 0, right? You guys see that? X is pi over 4. That implies y is 0. Okay, so when I plug these two numbers in there, this term with the y in it's going to go away. And so I'm going to have a 2 sine squared of pi over 4 plus tangent of pi over 4 plus 0. So I guess equals c. And then let's see, what's sine of pi over 4?
Root 2 over 2.
Yeah. So I got 2 times 1 over the square root of 2 squared plus tangent of pi over 4 is 1. Is a constant. So I think I got c as 2. You guys with me on that? Or k, I guess, since I relabeled it. K is 2.
Yep.
So we should be able to make that substitution, and that would tell me that this whole puppy here, oops, I can dump this part and put 2. Ooh.
Tiny. Oh, there we go.
One of the buttons on this little tablet does something very strange, and I should just turn that button off. All right. Yeah, and then I suppose you could go out and explicitly calculate here, but I'm not very inclined to.
Great. Neither was I. So I just kind of wrote that down and said, screw it.
Yeah, again with these, if you're not sure whether what you've got matches the back of the book, you have a couple options. We have found that Desmos is a pretty robust grapher. So you just graph the two solutions and see if the curves overlap. That works.
That's a good way of doing it. I didn't actually think of that. And
Oh,
since
yeah,
they're all in 2D, you don't have to use GeoGebra.
Well, we found that we also found that the two-dimensional GeoGebra isn't very smart.
It has a lot of limitations.
Jacob had a nice example of a function, well, not a function, but a set of implicit curves that GeoGebra just like test signaled out on, basically.
I've noticed that GeoGebra's engine has a couple of weird limitations when it comes to implicit functions. That, like, if you have certain powers on certain things or certain trig functions, it just doesn't graph it.
Yeah, I have a sneaking suspicion that the way GeoGebra's backend works is that it tries to pretend it's a function, solve for it, and then graph it.
And if you have an unsolvable implicit function.
Yeah, and it's just oftentimes it's not particularly able to solve those implicit functions explicitly, and so it just fails, or it'll draw part of the curve but not all of it.
Right, because the function that it solved for it was invalid for certain parts of the domain or something like that.
Yeah, it's also doing a sampling approach too. So if it's getting lots of points that are on basically a vertical line, it has real trouble drawing that.
I think probably how Desmos does this is it does some kind of Taylor polynomial approximation for it instead of some type or some kind of.
One of the things about graphing is you can just check all the points in the space.
That's true. It may just do that.
And to be completely honest, that will make a very robust grapher. It's slow, but it graphs things correctly.
And then if you're smart, you can do basically like a sparse checker where it checks a low quantity of points, finds ones that are valid, and then only checks points near those that it estimates will be on the curve of the function.
Yep.
And just sort of gradually increases its resolution the closer it thinks it's getting to the function curve.
Yep. Yeah. So that's some kind of a meshing approach, which is which is a pretty common tool. All right, I think I ran you guys out of time. So
Sorry about that. But yeah, that
oh
was
no,
all the
it's all good.
questions I had.
It's